Question 2. Okay, this question is about the hydrolysis of ester. Okay, we have ester X with this formula CH3COOR. Okay, R is alkyl group, and the ester X undergo alkaline hydrolysis with the aqueous potassium hydroxide. And after the hydrolysis, then the reaction mixture will undergo this acidification with the HCl, and it will produce the ethanoic acid and the alcohol. So we need to know the identity of alcohol, then we can get the structure of X, okay, which we will use the NMR later. Okay, so now we have 6 steps. Okay, step 1. Equal molar quantities of the ester X and KOH placed in the round bottom flask. A few drops of suitable indicators are added to show whether the reaction has occurred. This one I will discuss with you to choose the correct or suitable indicators for the reaction. And step 3, a substance is added to promote smooth boiling. This one must be the anti-bumping granules. Okay, so something like this one. We just need to add a few particles into the reaction mixture. Then the reaction will not, or the boiling will not be so vigorous. And okay, the reaction mixture is set up for the reflux for 30 minutes. After 30 minutes, then the mixture is acidified by the HCl. Then of course, later part need to use the TLC to test this reaction mixture. Okay, then for A part 1, complete the diagrams 2.1 to show the setup for reflux. Okay, reflux, there are two major components. The first one, of course, is the round bottom flask, and another one, the most important one, is a condenser. So you must draw the condenser in this figure 2.1, direct attached to this round bottom flask, and of course you must draw the water in out the direction. Is from the lower part, okay, then the water out is the higher one. So why we want to do this? Because we need to make sure the water get into the lower part and fill up the whole condenser. Then when the reaction mixture boil, the hot gases, when it's go up, because now it's fully covered with the water, means the hot gases, it will undergo condensation and drop back, right? So that's why the water in direction must be here. And okay, part 2 already told you the one that we use to promote the smooth boiling, okay, is anti-bumping granules. And okay, part B, we have the indicator that use. So we have 3 indicators: dimethylene, methyl orange, and the bromocrystal green. Before we discuss this indicator, let's look at the reaction. During the hydrolysis, you need to understand the carboxylic acid, means the ethanoic acids will produce. So this ester, during hydrolysis, it will form ethanoic acid. Okay, because it's alkaline hydrolysis, the hydroxide initially is already inside the mixture. So the hydroxide, then it will react with the acid that produced to form this sodium ethanoate, means the carboxylate salt. So which means the sodium hydroxide will get lesser because of the formations of the acid. So which means the pH change, initially it must form around 14 to 13, and it will drop, it will decrease. So it will change from 14 to around 6 to 7. So this is the pH change during the reaction. It's just because the reaction is start from sodium hydroxide, and because the formations of the ethanoic acid, which reacts with the sodium hydroxide, and this amount getting lesser, therefore the pH change will be there. So the suitable indicators that can be used must within the pH change. So since the pH change is around 14 to 7 or lower, so because it's weak acids that produce, so means it's a reactions between the strong base and weak acid. So the titration curve that you learn in the AS, okay, something like this, the pH range is here. So we must find the suitable indicator within this pH change. So in this table, only dimethylene, the pH change means the pH range which is change color is 9.5 to 10.5, which is within this pH range. Okay, that's why dimethylene is the more suitable indicators for this reaction. It will have a color change. Whereas for the methyl orange and the bromocrystal green, because the pH change for them is in acidic range. So means most likely this will not really change color during the reaction because it's not in the range, not in this range, right? So if you understand, then you can explain, follow this what I call this theory. So dimethylene is the more suitable or the better indicator. Why? Because there is a reactions between KOH with the weak acid that produce, and okay, therefore the pH would from about 14 to 7. Okay, the pH will decrease, and it will definitely from 14 to lower. So we must choose the indicator which the pH range is within this 14 to 7 or lower, right? So therefore only dimethylene is the suitable one, a more suitable one in the table. That's the explanation. Yeah. Okay, try to use this. And for the part C, in step 6, a small sample of reaction mixture is analyzed along with the samples of ester X and ethanoic acid. So this is the chromatogram from the TLC. Initially, it's actually like this. This is ester and the reaction mixture and ethanoic acid. We just spot on this line, and let the mobile phase run. Let them separate. So after separation, we will see this few spots. Okay, after separation, we know that there is an acid inside the reaction mixture. Sorry, there is ester inside the reaction mixture because this spot same retention factor with the ester X, and also there is acid here, right? So this is a spot. So because both the retention factor same. Okay, this is a retention factor of the ester X. Okay, so we know that this spot is ester. Okay, this spot is the acid. Okay, now the question asks, state what feature on the chromatogram shows the hydrolysis is incomplete. Hydrolysis incomplete means ester is still there. So in this chromatogram, okay, because of this spot which similar retention factor with the ester, so we know that is incomplete. That's how you relate them. So there is a spot in the reaction mixture. Okay, so this one, which same retention factor with this ester. So we know that is incomplete. Okay, part D, suggest an experimental process that could be used to extract the alcohol from the reaction mixture. Okay, once the alcohol produced, we can easily separate this using the fractional distillation. As long the compound in the mixtures they have different boiling point, so they can be separated one by one. Okay, using this fractional distillation. Okay, again, as long they're having different boiling point, so we can use fractional distillation to separate them. Part E. So figure 2.3 is the IR spectrum of the alcohol that extracted just now, right after this fractional distillation. So this one is this IR spectrum. Okay, let's see what they asked. Use the table 2.2 to explain how the IR spectrum shows that the alcohol extracted does not contain any ester. Okay, so then you need to check this table. Where is the ester? Most likely you just okay, because this one is from 1000 to 1300. Here is a fingerprint reagent. Sometimes quite hard to see. It's better for you to aim for this part, the CO double bond, right, for the ester. So you choose this one. If there is ester, then you see absorption within this range, 1710 to 1750. Okay, so around 1700 you cannot, okay, this one no absorption at all. So means in this sample there is no ester in there, right? Because here no absorption means okay, that's the answer. Spectrum does not contain absorption at 1710 to 1750 wave number. So now part F, we have this proton NMR. Okay, so try to draw the structure to explain which is more effective. So this is alcohol that produced this NMR spectrum. Okay, first, how these doublets produce? So these doublets produce from the methyl group, and actually you can get this info from the table here. Okay, it say methyl, right? The methyl is the one that form doublet, and there are 6 protons there, so means 2 methyl. From here we know that it's 2 methyl. And these 2 methyl must couple with the neighboring proton. So means this methyl and this methyl, they are equivalent. And this one as one unit, it will couple with the neighboring proton here. So means 1 and 1, 1 plus 1 is 2, means doublet. So it will form this doublet, means these 2 methyl group will form the doublet. Okay, the multiplet here is from this proton. So this proton. So this proton will couple with this 6 proton to form this multiplet. And this CH, this one, this alkyl group is next to O. That's why the chemical shift is a bit more positive. So you can check the table here. When the alkyl group is next to electronegative atom like oxygen, the chemical shift is around 4. Right? So roughly we know that these multiplets, this hydrogen that produce a multiplet must next to oxygen. Right? The CH here must next to oxygen. And the one that around 2.2 ppm here, this one, it must belongs to the OH. Right? You can check from this table, but the range is quite large. It's 0.5 to 6. Whenever you see a signals here, then it's possible to be this OH in alcohol. So once you understand, then you can fill up the table. 1.2 doublet, and this relative area 6 means 6 proton, and the structure responsible is the methyl. I told you just now. 2.2 is a singlet here. This one, the singlet. So it's from the OH. So 2.2 splitting pattern, you just put singlet, and relative area is 1. Okay, it must belongs to the OH. Okay, around 4.0 is the multiplet, only 1 proton, and you need to draw this structure. How to draw this? Okay, this one. Okay, because this one, the CH now is bonded to 2 group and is next to O, right? So this is a structure. Means this proton, why the chemical shift is around 4? Because this alkyl group is next to the O, right? This is a structure you need to draw. Okay, put it here, like this. Okay, name of the alcohol is quite obvious now, is propane 2O. So when we know it's propane 2O, then we can know the structure of ester X, which is this one. This part is from the propane 2O. Right, this one is from the ethanoic acid. Okay, ester X will undergo hydrolysis with water in the presence of the strong acid using the similar procedure. Suggest why none of the indicators in 2.1 would change color. Of course, because this is a strong acid, the pH is always below 3 or 2. So the indicator in the table, their pH change range is above 3, as you can check here, or above 3. So these 3 indicators, of course, is not suitable. So it's hard to find the indicators for the this hydrolysis, right? Okay, that's all. Thank you.